Okay, so if we go to the structured questions, so from this one, okay, so the first question, it asks you to draw a setup for collecting ammonia gas. Okay, so there are two key points you need to show on your diagram. The first part is that you show the reagent, okay, which is given. Is it? Yeah, okay. And then you need to somehow show that you need to warm the test tube, warm the two reactants. Okay, quite a few of you have missed that part. Okay, you need to warm it or heat it. You can draw a Bunsen burner, okay, to show that part. And then on the right hand side, you need to show something to collect the gas. And since ammonia is lighter than the air, so you need to draw a setup like this. Okay, so the ammonia gonna comes in to the top, and then it gonna pushes the air down so that you can collect a tube of the ammonia gas. Okay, so I've seen a lot of you join the drying setup, like the horizontal one with the drying agent in it. Okay, so that part is to show the drying process. It's not how you collect it. So after your drying tube, you still need a setup like this to collect those gas. Okay, you need to put it into a container to collect those ammonia gas. So that's the important part for this question. Okay, the heat and also the collecting part. Okay. Then to the next one, I have received some students ask me about these questions while you do the exercise. Very good. So if you encounter any questions while doing the exercise, just message me, okay? Don't leave it blank, okay? So for this one, the first question asks you to explain why the water containing phenolphthalein was sucked into the flask. Okay, so you have learned some physics, and I believe you need to be better at physics than me, okay? So if you know something gonna be sucked into the closed container, it must be due to the pressure difference. Okay, so that because it's go in, so the inside should have a lower pressure. Okay, but how? Why is the pressure dropped inside the flask? So what do we do to decrease or lower the pressure inside? Okay, so we dropped a few water in it. Okay, and we know ammonia can dissolve in water to form ammonia solution. Okay, so there are less ammonia gas particles in the flask, okay, because it dissolved in the water. Hence, the pressure inside the flask decreased. Then the water would be sucked into the flask due to the pressure difference. Okay, so you need to mention that part in your answer. Is soluble in water, ammonia is soluble in water. That's the first mark. And then you need to say due to the pressure difference, then the water containing phenolphthalein gonna enter the flask from the bottom flask. Okay, so that's for B1, and for B2, state with explanation and observation related to phenolphthalein in the flask. Okay, so quite a few have mentioned it changes from colorless to pink. Very good. But when you explain the reason, you need to get the key words here. Okay, a lot of you stated ammonia gonna react with water to provide OH minus. Okay, but you didn't link the OH minus to the pink color. Right? You're missing one sentence in between. So you need to mention when ammonia dissolved in water, it will form OH minus. It's a OH minus which makes the solution alkaline. Okay, and phenolphthalein gonna turn into pink when in alkaline solution. Okay, so you need to make your answer more complete. So that's for this one. Okay, and we got the last question. Question 9 is optional, and I want to discuss that with you when we have no normal face-to-face lesson as a revision. Okay, so singular, or we get some short answer questions like this. Okay, so it's quite common that you see questions ask you to provide a chemical test to distinguish between the substance. Okay, and later next year in grade 11, you're gonna see this kind of question again. So chemical test, that means you need to put something in that's gonna react with both of the substance, or react with one of the substance. Okay, so for the first one, iron 2 sulfate and iron 3 sulfate. I saw a few students write iron 2 sulfate solution is green, iron 3 sulfate solution is yellow. So you distinguish them by the color. Okay, remember it should be a chemical test. Okay, if you just by observing the two solutions and distinguish them, you didn't answer the question for this part. Okay, so you need to mention, I need to add something to the solution. For example, we can choose to add sodium hydroxide solution to both of the solution. And then iron 2 sulfate will give you a green precipitate. And then iron 3 sulfate will give you a reddish brown precipitate. Okay? And you need to mention it's not the solution that changes to green. Okay, it forms a green precipitate. And also for the iron 3, yes, again, it's a reddish brown precipitate. It's not the solution changed to reddish brown. And another question that I have seen in your answer is that some student just said add hydroxide ion or add hydroxide solution to these two. Okay, you will not be able to find a solution that only contains an anion. For example, a solution that only contains hydroxide ion, or a solution that only contains aluminium ion. Okay, impossible to do that. They will always stick to a oppositely charged ion. For example, a cation should always stay with an anion in a solution, although they are separate. Okay, they're gonna be able to move around, but both of the ions need to be present in the solution. So when you're stating your method, you need to mention a substance that contains the ion you want. Okay, don't just mention the ion itself. Okay, it's not practical. Okay. So for this one, you need to mention sodium hydroxide solution. So don't write just putting hydroxide ion solution. Okay, that's not practical. Okay, for the second one, solid ammonium chloride and solid potassium chloride. Okay, so for ammonium salt, I have mentioned there is a very, very important reaction you need to remember. Is to put it with an alkaline and warm it gently. So it will release a pungent gas. So a lot of you remember that part, but you forget that you need to warm it gently. Okay, don't forget the condition. And then state the observation. If the pungent gas is observed, then it's going to be the ammonium chloride. Okay, so that's for part B. Part C, okay, dilute hydrochloric acid and dilute nitric acid. Okay, so you need to remember all the nitric salts are soluble. However, for the salt that contains chloride, okay, since it's an halogen, there are two exceptions that it will form precipitate. It's silver, okay, A and P, so lead 2. Okay, so here you can add something that contains a silver ion. So here a good example is silver nitrate solution. Okay, it's soluble, so it can form a solution, and also it provides the silver ion. Okay, and when it react with both of the solution, actually it will only react with hydrochloric acid and provide the precipitate. So it would not give any reaction when you put into the dilute nitric acid, so that you can distinguish them. Okay. And for the last part, you got dilute sodium hydroxide and dilute aqueous ammonia. So both of them are alkaline solution. But remember, we have learned two special types of a reaction related to excess sodium hydroxide solution and excess dilute aqueous ammonia solution. Okay, and you can remember some of the difference between these two solutions. For example, in sodium hydroxide solution, there are 3 special metal ions that can redissolve in excess hydroxide solution as lead, zinc, and also aluminium. Okay, these 3. But for dilute aqueous ammonia solution, only 2 special cases that can redissolve. Okay, so maybe I jot it down so easy for us to compare. So for hydroxide, it's lead, Pb, zinc, and aluminium. And for aqueous ammonia, is zinc and copper. Okay, so you can see the difference. If you choose to use lead or aluminium, then it will be able to redissolve in excess sodium hydroxide solution, but it won't be able to redissolve in ammonia solution. Or you can choose to use copper. Okay, so when adding excess of that solution, copper will redissolve, but the one with copper cannot redissolve in excess hydroxide solution. Okay, so not just these 2, you can also mention copper. Okay, and for here, remember, if after you choose the correct solution, you need to mention it's gonna redissolve in excess alkaline. Okay, excess. Because some of the students forget these keywords. Okay, both of them gives a white precipitate, but one of them gonna redissolve in the excess solution. So that's how we distinguish them. Okay, so that's all for the structured question. So anything that you want to ask now? For those 3 questions I have gone through. If you are fine with it, type in okay or no problem and let me know. Hello, are you still with me? Okay, so now I would like to go back to the MC part. Okay, so I will let you to see some of the hints, and also if you've got question, just ask. Okay, because you've done pretty well on the MC part this time. Again, I will post the answer on Google Classroom, and please do correction accordingly. If you got anything that you want to ask, send me a message. Okay, any questions so far? Can you be quiet? Okay, so for this one, decomposition means you break a bond. Okay, remember, they are for example, if they're covalently bonded or ionic bonded, there are strong forces between the atoms or ion. So if you want to break the bond, you must supply heat to do so. Otherwise, the bond will not break. Okay, so this process, it requires energy instead of giving out energy. So exothermic means you give out energy. Okay, and I think the rest two are pretty obvious. Okay, so any question on this page? Check my marking. What are you doing? Sorry, back. Okay, so here. Question 7. Okay, is that this page? Okay, so for this one, okay, consider the following experimental setup. We have zinc powder and we have the oxalic acid powder. Okay, so a colorless gas is given out when water is dropped. Which of the following statement is correct? Okay, so let's see what's going to happen. Okay, so when water is added to the solution, then the oxalic acid going to dissolve in water, and it can now release hydrogen ion to perform the acidic property. Okay, then if it become an acid, okay, in solution, it got hydrogen ions in it, and then can react with the zinc powder. Zinc is pretty reactive and it can react with acid at room temperature. So you're gonna turn into a colorless gas, which is hydrogen. Okay, so let's come back to the answer and choose the correct one. First, oxalic acid ionizing water to give hydrogen ion. Yes, okay, that's what I just said. And then zinc ionizing water to give zinc ion. So we have done experiment. Sodium, potassium, they're gonna react with water readily at room temperature, but not zinc. Okay, and then C, water react with oxalic acid to give the colorless gas. No. Okay. Just like yeah, it would just form a solution. It would not be able to release gas. Next one, water react with zinc to give the colorless gas. Again, no, because water cannot react with zinc at room temperature. So correct explanation should be A. And then for this one is 23, which of the following can distinguish a sample of limestone? Okay, remember I asked you to memorize some of the formula related to calcium. Limestone, what else? Limestone, quicklime, and slate lime. Okay, those three. Powder from a sample of table salt. Okay, so limestone, calcium carbonate, table salt, sodium chloride. So adding water. Yes, by adding water, because calcium carbonate, limestone is insoluble, but salt is soluble. So we can distinguish them by adding water. And then performing a flame test. Sodium can give a golden yellow flame, while calcium would give you a brick red flame. So that will show a difference. And then 3, adding dilute hydrochloric acid. So after adding acid to calcium carbonate, the limestone, it will release a colorless gas, which is carbon dioxide. But if you just add the dilute hydrochloric acid to sodium chloride, it should be no reaction. Okay, so in that way you can distinguish these two. So the correct answer should be D. Okay, next one. Anything else that you want to ask? Okay, so for this question, okay, just use a hint to help you. So acidic gas, remember these two examples, carbon dioxide, sulfur dioxide. Okay, and for carbon dioxide and sulfur dioxide would not react with the calcium oxide to form the salt and water. Okay, you can see there's no hydrogen in it. How can water be formed? Okay. And of course, using these two examples, you can see it does not contain hydrogen. Okay, and then move on. So anything you want to ask on this page? Okay, so question 19, this one, okay, it's optional because when you are still learning unit 14, you would not be able to do it, but I think you can understand it now, right? Is this one? Or I didn't put it? Whatever, okay. Yeah, if you got question, let me know on this page. Okay, which 19? This one or this one? 2013 or okay, this one. Okay, so which of the following statements about limestone is or are correct? So limestone, calcium carbonate. Okay, so it gives a golden yellow flame in a flame test. No, it should give you a brick red flame. Okay, and then it gives a colorless gas when heated strongly. Yes, that's a common reaction that you need to remember. So limestone under heat will change back to calcium oxide, okay, and release carbon dioxide. But if you want to make it, sorry, I will not mention that part here. Just remember that's a very important equation in chemistry. And then 3, it dissolves in dilute sulfuric acid to give a clear solution. Limestone calcium carbonate is insoluble, okay, so it will not be able to dissolve in water. And when it reacts with dilute sulfuric acid, it will form, so it will undergo this reaction. Okay, and we know calcium sulfate formed is insoluble. It's gonna form or cover on the surface of the limestone and stop the reaction. It's like this. Is it balanced? Yeah, should be. Okay, so it will not form a clear solution. Okay, the product that formed is solid. So just statement 2 is correct. Okay, and the last one, I didn't explain it clearly, is the question 20. So how to distinguish between zinc chloride and also calcium bromide. Okay, so first one, adding ammonia. Okay, so adding ammonia, remember the two special cases that I mentioned for ammonia solution when in excess, zinc and also copper will redissolve. Okay, the rest can't. Okay, so in that way you should know, okay, you can distinguish these two because zinc chloride, when it forms the zinc hydroxide precipitate, it will be able to redissolve in excess ammonia solution, okay, but not calcium bromide. So the first one is a possible way to distinguish them. And then performing flame test, right? Zinc would not give any color in the flame test, but calcium will give you the brick red flame, okay, brick red flame. Okay, so you can distinguish this two. But for the last one, evaporating to dryness. So we will be able to remove all the water that combine with these two salts. However, when it's dried, both of them will have a white color, so you cannot distinguish them. That's why 3 is not a possible way to distinguish them. Okay, so we just choose A, 1 and 2 only. Okay, so okay, are we okay with all the questions for? Okay, let me go back. Okay, so for 2018 question 6, dilute sodium hydroxide solution is added to 0.1 molar solution until in excess. Okay, keywords in excess. Which of the following combination is correct? Okay, so remember for sodium hydroxide solution, the 3 special case you need to remember is lead, zinc, and also aluminium. So these 3 are gonna re-dissolve. Okay, so for A, it will re-dissolve when in excess. C, it's gonna re-dissolve in excess. Okay, and B, okay, calcium nitrate, the white precipitate will not disappear. And for D, iron 3 sulfate, the precipitate will not dissolve. Yes, but the color is wrong. It's not dirty green precipitate. It's yellow color. Is it? Yeah, but the color is wrong. Okay, the green precipitate should be iron 2, not iron 3. Okay, so and the fourth one, this one. Okay, which of the following statements concerning sodium hydroxide and ammonia solution is or are correct? Okay, so first one, both of them can react with magnesium chloride. Yes, because magnesium chloride got Mg2+, so it provides a metal ion. So both of them would give the precipitate Mg hydroxide, magnesium hydroxide. Okay, so the first one is correct. Second, both of them can form a deep blue solution with copper hydroxide. Only in excess ammonia solution, it can form the deep blue solution. In excess sodium hydroxide, it will remain as a blue precipitate. Okay, so not for this one. And then sodium hydroxide solution can react with ethanoic acid, but ammonia cannot. Okay, sodium hydroxide solution, ammonia solution, they are both alkaline solution. And ethanoic acid is an acid. So acid and base neutralization reaction. Okay, so the third one is wrong. So the only correct statement is just A. Okay, the first one. Okay, anything else? Okay. Okay, remember to catch up all the missing lessons and missing homework this week, because next week we're gonna move on. Okay, I will post videos onto the Google Classroom on Monday. And the reason why I ask you to upload your complete notes, one, I need to track your progress. Second, I need to check whether you have jotted down the correct information. So do upload your notes onto it. Okay. And next week, I'll try to return your Unit 15 exercise to you. Okay, anything else you want to ask or want to talk to me?